Now I'm going to make a quick list here of things that might trip you up. Things that might trip you up. And actually, they're the same things, before I do that, they're the same things that we're going to have before. We can either have infinitely many solutions, or we can have no solution. And we talked a little bit before about how to examine these and how to recognize some of these, but we'll just go ahead and give you an idea of what this would look like if you saw it in 3 equations, 3 unknowns. Now the examples I'm going to give you are going to be pretty obvious. For example, this one. Now it doesn't really matter what I write next, does it? Because we can already tell that x plus y plus z can't equal 6 and 3 at the same time. If I were to say, well, let me try to eliminate z. Alright, so if I want to eliminate z out of this one, then alright, well, I'm going to multiply this one times the -1 and multiply this one times the -1. X plus y plus z equals 6 minus x minus y minus z equals -3. Well, I'm going to add it down and something 0 plus 0 plus 0 equals 3. 0 equals 3. Ah! And that's a lie. So that means there's no solution, because 0 cannot equal 3. Alright, so the same kinds of things that you're going to see in 2 equations and 2 unknowns, you would see in this kind of example as well. And the same thing goes for if you're solving something that has, say, x plus y plus z equals 1, 2x plus 2y plus 2z equals 2. Now again, it might not be this immediately obvious, but it will come out to this at some level eventually. So again, if I said I wanted to eliminate z, and I said, alrighty, so I've got x plus y plus z equals 1, 2x plus 2y plus 2z equals 2. Well, if I want to eliminate that z, I've got to multiply the top part by 2. And so I've got minus 2x minus 2y minus 2z equals -2. 2x plus 2y plus 2z equals 2. And I'll add them up, and I get 0 equals 0. So again, 0 equals 0, always true. So I have infinitely many solutions. Alright, so these are just things the same that you're going to see with the 2x2 systems, you're going to see with the 3x3 systems. About the only other thing that they can do to you to try to trip you up is, and I'm not going to actually work this whole problem out, but they could give you something like this where they say, 3 times x plus 2y, like this, and x minus 3y plus 4z equals -9, and 4 times 1 plus x equals -3 times z minus 3y. And when you see problems like this, don't panic. You're really not supposed to panic. What you're supposed to do is recognize, oh, I can simplify these equations. So I'll take my 3 and distribute it. So my first equation really isn't that. The first equation that I'm going to mess with, so it really isn't that. But I'm going to use 6x plus 3y plus 5z equals -1. I'm going to use as my second equation, I'm going to forget the first ones even exist once I write these out, minus 6y plus 8z equals -9. This last one you might have to mess with a little bit, because you'll have 4 plus 4x equals minus 3z plus 3y. So if you wanted to write them all together in a little pile, you'd have to, probably move your 4x over. So you've got 4 equals minus 4x plus 3y minus 3z, which would give you minus 4x plus 3y minus 3z equals 4. So, and now you just solve as usual, or solve as you would solve any other thing like that. So just know that if you have something that's not in standard pretty form, all you have to do is put it in your standard pretty form and then solve it from there and pretend nothing else ever happened.